Okay, so before we start our lecture for today, siapa ingat kita belajar apa last class? Who still remember what you have learned for last week? What you have learned for last class? Anyone?
Electromagnetic.
Electromagnetic, correct. Electromagnetic radiations. Okay. So saya dah bagi lecture nota dekat your class rep dah. You dah dapat ke semua? Adia pun dapat ke?
Dapat.
Okay, so boleh dah dapat lah. Okay, so sebab you all dah dapat kan? Okay, so before we start our lecture for today, so let's have this short quiz first, okay? Regarding class for last week, regarding topic for last week. Sekejap ya, saya cuba share link sekejap. Just a short quiz for you to test your what we call your understanding lah. Okay. Okay, wait. Okay, so saya share link. Sorry. Okay. So saya share link, then you in this code. Yang last week tak jadi tu kan? So cuba try buat semula. Okay. Alright. Okay, so you click dates and then you key in this code 336326. Okay. Okay, have you joined? Okay. Siapa ni? Peminat apa ni? Peminat yang handsome siapa ni? Okay, so lagi. Okay, nama semua ni nama pelik-pelik ni. Nama aku apa ni? Okay. Alright. Siapa ni 10 Muharram? Okay. Okay. It's just a simple question sajalah. Okay, siapa yang dah siap? Dah siap ke? Ni baru 23 orang ni. Kenapa ada yang tak join ni? Ni 25 orang saja. Sekejap. Mana lagi yang lain? Okay. Dah siap ke? Dah siap dah? Dah? Akmal? Dah siap ke?
Tengah buat tu.
Okey. Okey. Simple je tu. Soalan ni true false. True false. Okey. Siapa dah siap, bagi tahu ya. Okey dah. Okey lah. Okey. Bila you buat tu terus keluar jawapan kan? Betul tak? Okey. Itulah. So lepas you buat tu akan tengok jawapan terus lah. So you bertengoklah ayah jawab tu betul ke tak kan? Okey. So okey lah. So kalau semua dah siap, kita start untuk hari ni eh. So semua dengar tak saya cakap ni? Dengar jelas tak?
Dengar.
Dengar jelas. Okey, good. Okey. Sekejap. Mana saya punya tu? Okay. So for today, you will learn about matter, the structure of matter. Okay. So these are the learning objective for today. Okay. Sorry. Okay. So these are the learning objective for these topics. Okay. So kalau tengok quite long lah. So this topic quite long actually. Okay, 70 slide. Okay. So I hope that you boleh stay sampai habis kelas lah. Okay. Hujan ni kalau you rasa apa? Kalau you rasa saturated ke it's too much for you, so you boleh beritahu lah so that kita stop or kita rehat sekejap lah. Okay. So that we can take 5. So these are the outline for these topics. So you're going to learn about matter and element, the structure of matter, the subatomic particles, the Bohr's theory, the binding energy, and then about isotope, isobar, and isomer, and also about ionization and excitation, and the last one is about luminescence. Okay. So basically, this topic actually you dah belajar sebenarnya kan? Actually about for example like structure of matter, right? So basically you dah belajar during your secondary school. Betul tak? Am I right? Betul tak? You belajar kan? You belajar dalam subjek apa dulu? Siapa yang makin kimia kan? Okay, so basically you dah belajar matter, dah belajar atom, semua you dah. So actually it's like a revision for you lah. Okay. So hopefully you masih ingat lagi lah walaupun dah. Bila? You sekarang ni baru tahun 2 kan? So baru 2 tahun, betul tak? Baru 2 tahun meninggalkan SPM. Betul? Okay. So hopefully you all boleh ingat lagi lah. Okay. Okay. So what compose matter? Okay. So what is matter actually? Akmal, what is matter Akmal? Okay, Akmal. Hmm.
Dia bahan yang memenuhi ruang kot.
Alright. Okay. Fahda, what is matter? What is matter? Ada tak? Ya Fahda. What is matter, Fahda? Hmm? Fatihah Rosli. Fatihah. Okay, what is matter, Fatihah?
Ya, Doktor.
What is matter?
Everything that has mass.
Anything that has
Mass.
mass, correct. So anything that has mass, that has weight and that occupy the space is known as matter lah. Okay, so matter can be classified from as smallest as atom to the as large as universe. Okay, so anything that occupy the space, we call it as matter. Okay, so you can see here kan, you can see here, we nampak dalam figure ni. So there are anything that encompass in this universe is known as matter. Okay, the smallest one, atom tu dah kecil dah, tapi inside atom ada yang lagi kecil. Okay, so the subparticle of atom is the smallest matter. Okay, and the largest matter in this world, it is universe lah, our dunia ni lah. Okay, alright. Okay. Okay, so matter can be defined as anything that occupies space and has mass, shape, or form. And then the basic of matter, whether in solid, liquid, or gaseous form. And all matter is composed of molecules. Okay, so molecules they have a building blocks inside them, which is called. Okay, so anyone can give me example for matter, solid matter. Nur Aini, solid matter. What is example for solid matter?
Sekejap
Okay, yeah. Any idea? Anything? Anything depan you kan? Surround you, that have mass, that have shape. Okay, so it's not as matter. Solid matter. Example for solid matter? Raihana. Raihana, can you give me example for solid matter?
Ice, Doktor. Ice.
Okay, ice. Lagi? What else? Syaiful. Okay, Syaiful. Example for solid matter.
Laptop.
Laptop, okay. Alright, correct. Anything else that you can think of? Liquid, gas.
Liquid. Minyak masak.
Ya, masak, yes. Liquid water kan? Water yang you minum tu. Okay, so it is metal lah. Okay, solid like paper. Okay, so there is a matter in solid form. Gases like our oxygen kan? So all these are known as matter lah. Okay. Okay. Alright, element. So element is the simplest form. It is the simplest form in which matter exists. Okay, so matter yang paling simple adalah elements. Okay, so elements that you can find in the periodic table kan. So you belajar dulu kan dalam kimia tu, there is one jadual berkala kan. One periodic tables and inside them they have elements, numbers of elements, and there is about 108 different elements in the periodic tables. Okay, and each element they have different name and they have different chemical symbol, and each of them have different properties. Okay, and each element also have different or unique atomic number. Okay, and each atom inside element, they represent the properties of the element itself. Okay, for example, like elements of hydrogen and oxygens. So hydrogens, they have atom inside them that represent their elements. Okay, different between atom inside hydrogen and atom inside oxygens. Okay, so they have different element. They have different atom composition. Okay. Okay, so there are so many types of element lah. Okay. So all the elements are listed in the periodic table in ascending order of atomic number. So you can see, right? So you can see here, for example. Okay, so these are the periodic table. Okay, so inside this there are about 108 elements. Okay, so sangat banyak lah. And each element they have their own properties. Okay, and they are arranged in the ascending order. Okay, so atom. What is atom? What is atom? Biasa dengar kan atom. So what is atom? Izatul. Okay, Izatul. What is atom, Izatul? Izatul. What is atom, Izatul? Okay. Wait. Okay, so atom, it is the smallest particle that has all the properties of elements. Okay, so each element they have their own atom, and each atom it is the smallest particles inside the element. Okay. Okay, and this atom it is extremely small and almost concentrated in the nucleus part. So like Izatul mentioned tadi kan, have electron, proton, neutron semua tu kan. So for atom, their mass of course the nucleus region here. So this nucleus region, the mass of atom normally according to the nucleus mass lah. Okay. And the unit for atom is atomic mass unit, or AMU. Okay, or also or equal to the what AMU equal to the 1.6 times 10 to the minus 27 kg. Okay, so you kira lah berat you berapa. Okay, berat you berapa? Katakanlah berat you 60 kg. Okay, so atom, so you can see lah, very light. Okay, so inside your body itself there are atom, right? Okay, so very light lah. Okay, berapa juta dengan berat you. Okay, size atom, berat atom. Okay, so for the atom discovery, so basically the atom has been discovered by previous scientists. Okay, and they come out with a different theory and different model lah. And these are the famous the common theory about atom. Okay, the first one started with the Greek atom, then Dalton atom, Thomson atom, and the last one is Bohr atom, which is the one that we use at the present moment lah. So we apply, or we use this Bohr atom theory for our what we call untuk masa sekarang lah. Okay. So each theory they try to discover about atom, and they come out with many theory kan. Okay. So start from the Greek atom, the last Bohr atom. So hasil lah this structure of matter in form of proton, electron, and neutron. Okay, and you belajar tu lah. Okay, so So we apply the Bohr's theory for for learning about atomic structure. Okay, structure of matter. So so according to Bohr's theory, the atom is made of nucleus and also orbital electron. And electrons are negatively charged. Okay, and their numbers are equal to the number of proton. Okay, so they have inside atom they have electron and proton. So electron is negative, proton is positive, and they have equal number, so that the atom become neutral. Okay, and the electron is rotating in their specific orbit, in their specific track. Okay, like our universe lah. Okay, our universe we have sun, and then then all the planets are rotating around the sun in their orbit. Okay, so it is the similarity for the atom theory lah. Okay, and the innermost orbit for the atom it is K shell. Okay. Okay, so this is the illustration for the atom. Okay, so they have nucleus in the middle, in the center, and then the electron will rotating around the nucleus in their orbit. Okay. Okay, so this is the structures of atom according to the Bohr atomic models. So there is there is a nucleus in the middle, okay, and composed of proton and neutron. Okay. Okay, so anyone want to discuss or want to explain about this model, this atom models? Okay, so you dah belajar kan? So ni just revision for you kali ikutnya. Okay, so anyone want to try, want to explain about neutron, about proton, about electron, about orbit? Okay, ada tak siapa-siapa nak explain? Anyone want to try on or want to share with your friends? Megat. Hello Megat, are you there? Ada tak Megat?
Ada.
Okay Megat. Okay, choose one particle. Choose one subparticles. Okay, which one you want to explain to your friends? Okay, you can choose. You want neutron, proton, electron, or orbit. Okay.
Electron.
Okay, boleh? So tell your friend like tell a story. Tell story about electron to your friends. Okay. Cerita lah apa? Berat dia ke? Saiz ke? Jumlah ke? Terpulang lah. Whatever you want, whatever you know about electron. Apa-apa yang you ada idea about electron. Ya, charge ke?
Electron negatively charged.
Okay.
Bilangan dengan proton.
Okay. Lagi? Itu saja.
Itu je lah.
Okay. Ada lagi nak tambah? Nur Hisham. Okay, Nur Hisham.
Ya.
Okay, Nur Hisham. Okay. Okay. Which one you want to explain? Okay, about electron. You want to add further about electron or proton, neutron, orbit?
Proton.
Okay, boleh. Okay. What about proton?
Proton is a subatomic structure that is positively charged,
Alright.
located at the center of atom. Proton dia tak bergerak, dia just stated at there. Dia tak macam elektron, dia boleh bergerak ke mana-mana.
Okay.
And bilangan proton dia akan sama dengan bilangan elektron.
Okay, good. Okay. Any more? That's all.
That's all.
Okay, thank you Hisham. Nick Hakimi. Nick Hakimi, are you there?
Ya pun ada.
Okay. Hakimi. Okay.
Ya.
Which one you want to explain?
Saya tak pasti tapi saya boleh explain kot.
Okay.
Jadi elektron tu dia bergerak mengelilingi nukleus pada petala-petala yang berbeza. Jadi kalau petala paling hampir dengan dengan nukleus tu,
Aha.
mempunyai tenaga yang paling rendah.
Okay.
Jadi jika semakin jauh daripada petala, maka semakin tinggi tenaga arah dia.
Okay.
Itu.
Okay, betul. Okay, good. Okay, bagus Hakimi. Ain Syazwani.
Doktor?
Hello. Okay.
Okay.
Which one you want to explain?
Neutron.
Okay, boleh.
Neutron partikel dia ada sama dengan proton tapi tak ada charge charge elektrik.
Tak ada charge. Okay, betul.
Lepas
Mm-mm.
so
Ada lagi? Tak ada dah. Okay. Nur Ayuni. Okay, Nur Ayuni. Okay, Nur Ayuni. Which one you want to explain? You can choose anyone. Neutron, proton, or electron, or orbit.
Neutron, proton tu dia akan panggil nukleus.
Okay, correct. Okay, lagi ada lagi tak?
Tak ada.
Okay. Kok ada lagi nak explain ke? Okay, Irdina. Okay, Irdina. Irdina ada ke? Tak ada ke? Nurul Irdina. Nurul Irdina, are you there? Raihana. To try for the last one. Okay, Raihana. Ada tak? Okay.
Ada.
Sorry?
Neutron ni dia
Apa tu?
ada charge.
Yang mana tu? Kurang jelas Raihana. Explain yang mana tu?
Neutron.
Okay, neutron.
Neutron ni atom yang dia ada mass sampai proton tapi dia tak ada electric charge.
Okay lah. So basically you all semua dah tahu kan about structure of atom ni. So it's very basic actually. So basically semua benda ni you all dah belajar kan about atom, about the composition of atom, the subatomic particle inside the atom, the proton, the electron, the neutron. Okay, so good lah. Okay, so according to the Bohr's theory, electron travel in a circular path around the nucleus. So electron, they will rotate, they will circulate around the nucleus. And at normal living condition, at normal state, okay, the electron, they will reside in the closest orbit to the nucleus. Okay, and as long as the electron remain in their orbit, in a specific orbit or in their orbit, so energy is gained or lost by the atomic system. Okay, and if the energy is added to the electron, so the electron, they will move to the new orbit or excited state. So whenever we give energy to the atom, so the electron inside the electron in the orbit, they will shift, they will transfer to the excited state. Okay, they will transfer to the another orbit. Okay, and electron in the excited state, they will drop down, or they will drop down to the lower energy state, or they will return, or they will go back to the ground state. Okay, and during the transition from the excited state to the ground state, the energy will be transmitted. Okay. Okay. So these are inilah subatomic particle of the atom. So there is nucleus, and there is neutron, okay, and orbiting electron. Okay, so the combination between the neutron and proton also known as nucleon. Kan? Tadi ada member you cakap kan? Okay, proton and nucleon, they combine, they become nucleon. Okay, so the first one about nucleus. So nucleus, it is the massive central part of the atom, and composed of neutron, which is have no charge, and the proton, which is have positive charge. Okay, and the combination between neutron and proton known as nucleon. And this positively charged nucleus, they will hold negatively charged electron in specific orbit. Okay, so that's why lah electron tu they will rotate in their specific orbit. Okay, in the normal conditions, due to the charge between positive and negative charge, so they will remain in their position. Okay, and neutron and proton, they form the central core of the nucleus. Okay. Okay, so this is the apa panggil, the diagram for the nucleus. Okay, and like electron, the nucleon between neutron and proton, they also have the quantum properties. They also have the energy properties. Okay, including spin. Means that the nucleon, the proton, and the neutron, they actually moving. Okay, they are not static in their. They are static actually, but they are vibrating. They are spinning, but at the same location. Okay, not like electron. Electron, they're spinning, they're turning around. But for neutron and proton, they are spin, but in their position, in their one position only. Okay, so they are vibrating. Yeah, and spin value of the nucleus equal to the sum of the spin value between the nucleon. Sum value between between the spin value for the neutron and also proton. Okay, and proton. So as you know, proton, they are negative charge and they are positive charge. Okay, so they are actually repel each other. Okay, and inside the nucleus, there is nuclear binding force, which is the powerful binding force that hold the nucleon together very tightly. Okay, so there is very powerful nuclear binding force that hold them together. Okay, and the work or the energy that needs to overcome the nuclear force that hold them together, or to remove the nuclear from the nucleus, is known as nuclear binding energy. Okay, so the energy to remove the nucleon from the nucleus, it is known as nuclear binding energy, and their unit is EV. EV is electron volt. Okay, so the energy is very, very high lah. Okay, next about proton. So proton, so as you know, proton, it is positively charged, and their their amount is equal to the negative charge of electrons. Means that the positive charge of proton and negative charge of electron, they have the same magnitude, they have the same numbers. Okay, and proton, they are much larger and heavier than electrons. Okay, and their mass about this lah. Okay, the mass of atom actually is about the mass of proton. Okay, and in an electrically neutral atom, the positive charge proton, they combine with negative charge of electron. Okay, So in neutral condition, the positive charge and the negative charge between proton and electron, they will combine, so that the atom become neutral, become no charge. Okay, because they are cancel out each other. Okay, so so you have to remember that in natural state, the atom it is no charge due to the cancellation between the positive charge from proton and negative charge from electron. Okay, then about neutron. So neutron they have no charge. Okay, it is neutral and no charge, and it's also heavy like proton. Okay, and their weight was about weight of proton. Okay, so their mass is about weight of proton mass. Okay. Okay, then about electron. So electron, it is negative charge, and it is very tiny and very light particle compared to the proton and neutron, and it's a curl around the nucleus in specific orbit. Okay, and their mass were about 1/2000 of the mass of proton or neutron. It's very light compared to the proton or neutron. Okay. And there is a centrifugal force between the positively charged nucleus and negative charged electron. There is force between the nucleus and also electron lah. And this prevent the electron from exiting the atom lah, so that the atom remain in their position. Okay. Okay, then orbital electron. So, as you know, the electron, they will rotating around the nucleus in their orbit, in their shell, right? Okay. And what is orbital electron? It is the region where the orbital located at lah. Okay, it is the location for the electron. Okay, and each of the electron, they will circulate around the nucleus in continuous motion. Okay, they will continuously rotating around the nucleus. Okay, and the distance from the nucleus determine the energy level of the electron. Okay. Okay. So the closer the electron to the nucleus, the lower energy they have compared to the outer shell electron. Okay, so this is the orbital shells. Okay, so there are numbers of orbital shells. So the innermost one is K shells. Okay, and the outermost shell, it is Q shells, depend on the size of the atom. Okay, some atom they may have KLM, but for the bigger, or for the atom with higher mass, so they have more numbers of shell, more number of orbit. Okay, so for the closest orbit, which is K, they have 2 number of neutron only. Okay, but for the outermost layer, outermost orbit, they have many numbers of electron. Okay, for example, like Q. Okay, they have 98 number of electron in the orbit. Okay, and this is the formula to calculate the number of electron in the shell. 2 and power of 2 lah. Okay, so this is the equation to calculate the number of electron in the shell. Okay, so far okay? Are you okay ke?
Okay.
Alright, so far boleh faham Okay.
Faham, Doktor?
Okay, good. Okay, next about binding energy. So what is binding energy? It is the amount of energy needed to remove the electron from the atom. Okay, the binding energy, it is amount of energy required to remove the electron from the atoms. Okay, and it also refers to the strength of the attachment between electron to the nucleus. Okay. The closer the electron to the nucleus, the more tightly it is bound to its orbit or shell. So that is more difficult to remove the electron. Okay. So the closer electron to the nucleus, they more tightly bound compared to the outermost or the electron that situated far away compared to the nucleus. Okay, so electron yang dekat dengan nucleus akan lagi tinggi binding energy dia, akan lagi susah untuk nak remove electron tu. Okay, and each orbital, each shell of electron, they have their own specific binding energy. For example, like K shell, L shell, so they have their own specific binding energy. Okay, so the binding energy of electron, they will decrease as the distance from the nucleus is increased. Okay, and the electron in the outermost shell, in the outermost orbital yang paling jauh, they are loosely bound to the nucleus. It's called free electron. Okay, free electron. So free electron, it is in the outermost shell, yang paling jauh. Okay, and the unit for the binding energy of electron also in electron volt, eV. Okay. So more energy is required to remove K shell compared to the another shell, compared to the L, M, N. Okay. So kalau yang paling senang nak remove, which shell? Which electron? Which electron is the easiest to remove? Anyone? Which electron is the easiest to remove in the atom? Iza?
Elektron yang paling jauh.
Okay, good. Zakwai, which electron is the easiest to remove in the atom, Zakwai? K or N? K shell or N shell? Electron in K shell or electron in N shell? Zakwai. Ke tak ada Zakwai hari ni? Vincent, which electron is the easiest to remove? In K shell or N shell?
N shell.
N shell, correct. Okay, so the fathers the panggil paling jauh kan, whenever the distance increases from the nucleus, so that they are loosely bound, so they have lower binding energy, so they are easy to remove compared to the inner shell electron. Okay, so you can look at this figure. Okay, look at this figure. Semua nampak ke? Can you see this figure? Okay, so this figure, they have different atomic number, different proton number, right? Different mass. So they have different binding energy. Okay, they have different binding energy. Okay, so look at here. Compared to these three elements, which one is the easiest to remove? Which inner shell is the easiest to remove? Which K shell is easiest to remove? Okay. Siapa tu? Yang suara je, nama tak naik ni. Siapa tu? Zawawi. Zawawi ada?
Ya, doktor ada.
Okay, Zawawi. Cuba tengok sini Zawawi. Between the K shell kan, between carbon, barium, tungsten, which K shell is the easiest to remove, Zawawi?
Tungsten.
Easiest to remove? Between carbon, which K shell is the easiest to remove?
K shell tungsten, doktor.
K shell tungsten. Hakimi.
Ya, doktor.
Okay, which one? Which K shell is easiest to remove?
Tungsten.
Tungsten? Okay, why you mention tungsten? Okay. Irdina. Okay, Irdina. Which one? Which K shell? Paling senang to which electron in K shell is easiest to remove? Carbon, barium, or tungsten?
Dalam carbon.
Carbon. Okay, so correct. So the answer is carbon. Okay. Kalau tengok sini kan, you tengok sini, nampak tak binding energy ni? Okay, so carbon dia paling kecil. Okay, they have low atomic number, low mass number. Okay, so they have low binding energy. Okay, so kalau you tengok sini, the higher the atomic number, the higher the mass number, the binding energy will increase, right? Okay, so whenever whenever there's increase in the atomic number and mass number, their binding energy is increasing, so that their binding energy also increasing. Okay, so in this figure, the hardest electron to be removed in the K shell, it is tungsten. Okay, kat sini nampak kan binding energy dia. Binding energy for tungsten in K shell 70. Okay, so susah nak remove compared to the carbon. Carbon is just 0.3 for the K shell. Okay, and similar to the barium, 37 only. Okay, so here the easiest electron in the K shell to remove is the carbon lah. Okay, because they have lower binding energy. Okay, so you have to understand lah. Okay, and the next one is energy levels. So energy levels, it is the electron near the bottom. The bottom level are the lowest energy level. Okay, so electron at the lower and at the bottom level, they have the lowest energy level. Okay, but they have the greatest binding energy compared to the outermost layer. Okay, so electron in the K shell, they have low energy level compared to the M shell. Okay, and each shell, they have different energy levels. Okay, so the K shell, this is the closest to the nucleus, it have the lowest energy levels compared to the L compared to the M. Okay, alright. So so you tengok sini lah. Okay, so the K, they have low energy level compared to L and compared to M. Okay. Okay, so you nampak Okay, so how atom of element are expressed? Okay, so you have in the periodic table, there are so many elements, right? And each element, they have their own chemical properties, and they have their own different symbol. Okay, and each element in the what we call in the periodic table, they have their own atomic mass and they have their atomic number. Okay, so the atomic mass, it is their symbol is A. Okay, and for the atomic number, their symbol is Z lah, Z or Z lah. Okay, So atomic mass, it is the composition or the combination or the total between the proton number and the neutron number. Okay, and the atomic number, it is the um, atomic mass minus the neutron number, or it also known as proton number. Okay, so atomic mass, it is proton and neutron. Meanwhile, atomic number, it is proton number. Okay, or atomic mass minus neutron number. Okay, so you have to know lah how to find the proton number, how to find the neutron number. Okay, from this symbol, from this atomic mass, from this atomic number. Okay. So as you know, in neutral atom, in neutral state, the number of proton and the number of neutron are equal number. Okay. 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 So what is atomic number? So atomic number, it is number of proton in the atom, and it is represented by the symbol of Z or Z. Okay. And it is determine the chemical properties of the atom, and is define the element of the element inside the periodic table. Okay. So for example, like helium, there has 2 proton, so that their Z number is 2 lah. The atomic number is 2 lah. Okay. Ini terbalik ni, sorry. Ni atomic number kat bawah ni, mass kat atas. Okay. And hydrogen, they have 1 proton. So their atomic number is 1. Okay. Okay, atomic number is normally Z lah. Yang ni salah tau, yang figure ni. Okay, so nanti I buang lah. Okay, so atomic number. So you can see lah. So what is the atomic number for the helium? Huh? 2. Okay, correct. Okay. Okay, so you better differentiate lah. So this is, and the smallest number tu, it is refers to the atomic number. The smallest number for the element, it is refers to the atomic number, while the biggest number ni refers to the atomic mass. Okay, then about mass number. Mass number, normally the symbol is A. So mass number, it is the sum or the total value of the proton and the neutron in the atom. And it is also known as atomic. It is also known as nuclear number. Atomic mass, nuclear number, or also mass number. It is the same thing. It refers to the atomic mass, A. Okay. So the mass number, it is the difference between the mass number and atomic number give the number of neutron. Okay, so you can see here lah. Okay, the atomic mass minus the atomic number, they will give the neutron number of the nucleus. Okay, the neutron number in the atom. Okay. Alright. So are you okay? Sampai sekarang okay ke? You nak take 5 ke? You guys want to take a break for a while? Boleh? Nak take break ke? Before
Boleh.
Boleh? Okay lah. Kut nak pergi minum air ke dapur ke? Okay. Awak nak pergi toilet ke? Boleh lah. Okay, so kita take a break for 5 minutes, okay? Okay, lepas ni saya sambung balik. Alright. Okay, boleh sambung semula ke? Nah, dah siap dah pergi toilet semua? Nah, boleh sambung ke? Okay. Okay. So, dah kembali ke tempat masing-masing ke? Okay. Alright. Okay. So, kita sambung lagi. Ada sikit lagi baru separuh ni. So, the next one is about isotope, isotone, isobar, and also isomers. Okay. So, what are all this? Okay. So, what is isotopes? Okay, so isotope, it is the atom that have the same number of proton, okay? But they have different number of neutron, okay? So means that for the isotopes, the atom, they have same number of protons, okay? But they have different number of neutrons, okay? In other words, this atom, they have same atomic number, but they have different mass number. Okay. So look at this figure. Okay, so this atom, it is the same element. It is the same atom, the same element. Both are iodine. Okay, but they have different atomic number and they have different mass number. Okay. They have the same atomic number but they have different mass number. Okay, so kalau tengok sini, so for these two atom, they have the same proton number. They have the same atomic number. Okay, but they have different neutron number. Okay, so that they will have different mass number. Okay, but they have the same atomic number. They have the same proton number. Okay, so they are the same element, but they are isotopes. Okay, which means that this atom have different composition of the neutron. Okay, or they have different number of mass number, atomic mass. Okay. So the isotopes is refers to the same elements. Okay, the same element, but they are isotopes. Okay, so these isotopes also called as nuclei. Okay, and several elements, they may have several type of atoms. Okay, so let's say for iodine tadi, they have different atoms with different mass number, different neutron number. Okay, for example, like this chlorine. Okay, this chlorine, they have different. For example, kat sini ni, what's the difference between these two chlorine?
Atomic mass.
Yeah, atomic mass. Okay, so they have a difference in their atomic mass, but they have the same proton number. They have the same atomic number. So that refers to that is called as isotope. Okay, and the next one. Okay, this is another example for the isotopes. So this is example for the hydrogen. Okay, so for hydrogen, there are few types of atoms for the hydrogens. So there are 3 isotopes for the hydrogen. Hydrogen depends on their neutron number. Okay, so all these hydrogen, they have the same atomic number, but they have different mass number. Okay, so there are plutonium, deuterium, tritium, tritium. So there are depends on their atomic mass. Okay, so that is called isotope. Okay, so these are another examples for isotope lah. Okay, this one for phosphorus. Okay, next one is isotone. So what is isotone? So isotone, it is apa nama tu, terbalik dengan isotopes. It is isotopes. So if isotope, they have different number of neutron, but for isotone, it's reversed from the the isotope, different mass number and also different atomic number. Okay, they have different mass number and they have different atomic number, but they have the same neutron in the nucleus. Okay, the same number of ni betul ke tak ni? Sorry, salah kat sini ni. Okay, sorry, wait. Sekejap, saya kecilkan dulu. Saya nak kecilkan. Okay. Have same number of neutron. Same number of neutron, different number of proton. Okay. Okay, so for isotope, they have different number of proton number. For isotope, the atom have a different number of neutron, but for isotope, they have different number of proton. Okay, so look at in this figure. Okay, so this isotope normally is refers to the different element, but they have same number of neutron. Okay, and they have different number of proton. Okay, so this element, this atom is called isotope. Okay, so they have different mass number, different atomic number, but they have the same neutron number. Okay, so that is isotope. Okay, and then the next one is isobar. So for isobar, this atom, they have different element. Different element have the same mass number, but they have different atomic number. Okay, so this is called isobar. So these two element, these two atom, they have the same number of mass number. Okay, but different atomic number. So it is known as isobar. So actually dia adalah benda yang berbeza lah. Okay, benda yang berbeza, but they have the same atomic mass. Okay. So for isobar, since the number of electrons are different, so that the chemical properties of the elements are different lah, because they are different elements. So they have different chemical properties. Okay. Okay, the next one is isomers. So what is isomers? Isomers is an atom, but they have two nuclei that they have the atom that have two nuclei that have the same compositions. Okay, the atom that they have two nucleus that have the same compositions. Okay, they have the same atomic number and also the same mass number, but they have different energy state. Okay, so that refers to the isomer. Isomer, same atomic number, same atomic mass, but they have different energy state. Okay, so for example, like this lah. This one technetium, and this one they have different energy state. This one 99 M, this one technetium 99. Okay, so they have different energy state. Okay. So these are examples for the isotope, and also isobar. Okay, so this table summarize the arrangement for the isotopes, isobar, and isotope, and also isomer. So you can use this lah to remember the difference between these four category. Okay, these four nuclear arrangement, okay, that they have different term and they have different arrangement in the proton and neutron number. Okay. Okay, so because this one a bit confused kan, isotope, isoton, isobar, isomer. Kalau dengar macam sama kan, dengar macam sama je semua. Tapi actually they are different lah. They have different composition of the neutron and different composition of the proton, and they have different energy. Okay. So what is isotope? What is isotope? Farhan. Okay, Farhan. Farhan tak ada. Farhan left meeting. Farhan tak ada coverage ke? Akmal. Akmal, what is isotope, Akmal? Cuba refresh balik.
Isotop tu.
Ah.
Isotop ni dia same number of proton, satu different number of neutron.
Okay. Vivina. Betul ke saya panggil?
Betul.
Betul. Okay. Okay. Baik, betul. Okay. Okay, Vivina. So what is isotope, Vivina?
Isotope has the same number of proton, different
Alright.
number of atomic mass, and neutron.
Okay. So isotopes, they have what are the same among them?
Proton numbers.
Proton numbers. Okay, so proton numbers. So they have the same proton numbers or the same atomic number, right? Okay, so that is isotopes. So what about isotone? Alia Najwa. So what about isotone, Alia?
Isotone have different atomic mass and atomic number, and have same number of neutron.
Okay. Vincent. What is isotone, Vincent?
Atom with same neutron
Isotone.
number but different proton number.
Isotone. What's different among them? What's different among the isotone atom?
Different neutron number.
Different neutron or proton number?
Neutron number.
Nuclear number?
Uh,
Nuclear number. What?
Different proton number.
Proton number. Okay, they have different proton. They have the same neutron, but they have different proton number, right? Okay. Okay, so that they will have same atomic mass or different atomic mass between the atom. Between the atom, so they will have different for isotone. So they will have different atomic number and also different atomic mass. Okay, because they have different number of proton. Okay, same number of neutron but different number of proton. Okay, so you kena ingat lah yang ni. Kadang-kadang kalau susah lah nak ingat kan, tapi cubalah untuk ingat. Okay, that arrangement. What about isobar? What is isobar? Fatihah. What is isobar, Fatihah?
Ya, Doktor.
Isobar tu apa?
Isobar is atom that have different element. Different element that have same mass number and different atomic number. So the chemical properties will be different.
Okay. So basically for isobar, they have same atomic number or atomic mass?
Atomic mass.
Atomic mass. Okay, correct. So for isobar, the atom they have the same atomic mass but different apa?
Atomic number.
Atomic number, correct. Okay, what about isomer? Max, apa ni nak panggil apa ni? Max kan? Okay, Max, are you there?
Ya, Puan.
Okay, Max. So what is isomer?
Isomer atomic number je sama. And then how to say atomic number, atomic mass number dengan neutron number je semua sama.
Okay, so what's the difference between the atom? Apa beza dia? What's the difference between the atom of isomers? Zakwan? Zakwan ada tak? Zakwan tak ada ke hari ini ni? Kezakuan menyepikan diri ke tak ada coverage ke apa ni. Okay. Hakimi. What is isomer Hakimi?
Ya doktor.
What is isomer Hakimi?
Isomer ni dia adalah atom yang mempunyai 2 nukleus.
Okay.
Jadi dia mempunyai atomic number dengan atomic mass yang sama.
Alright. So what's the difference between this atom?
Yang berbeza dia adalah tenaga yang dihasilkan.
Okay, betul. So their difference is their energy properties, kan? Energy or properties between this atom. Okay, so that is known as isomers. Okay. Okay, then the next one is about tajuk ini ni. Okay, this one is ionization process. So what is ionization process? It is the process where the incoming energy of radiations, they have sufficient energy to remove the electron in the shells. Okay, remove the electron from their orbital. Okay, so it is called ionization process. The incoming radiations, the incoming energy of radiation photon, they have more energy compared to the binding energy of the electron here. Okay, so that they are able to remove the electron in the shells. So this process is called ionization. Okay, radiation has enough energy to remove electron in the shell, so it's known as ionization process. Okay, so whenever the electron is removed, the atom become what? Stable or not stable?
Stable.
Whenever the electron is removed from the atom is stable or not stable?
Not stable.
Not stable, correct. So bila radiations, they have higher energy compared to the binding energy of electron, and they are able to remove the electron. So whenever they remove the electron will be kicked out from the atom, so that the atom is not stable anymore. So that the atom become positive ion. Okay, the electron become negative ion, and the atom become positive ion. So that's why we call it as ionization. Okay, because the atom become ionized. Okay, so they will produce ion pair, positive ion and also negative ions. Okay, so what is the key for the ionization process? The energy of the incoming electron, incoming radiations, they must have higher energy compared to the binding energy of electrons, so that they can kick out the electrons. Okay, so that is ionization process. Okay, so the second one, it is excitation process. So it's different from the ionization process. So for the excitation process, the electron is not removed from the shell, from the atoms, so that the atoms remain neutral or remain naturals, but they have excitation process. Okay, so what is it? It is if the incoming radiation energy is lower than binding energy of electron, the electron will be raised from the lower shell to the higher shell level. Okay, so like this. So for example, like this incoming radiations, they have insufficient energy. They have lower energy compared to the binding energy of electron. So they are not able to remove the electron. They will excite the electron, so that this electron, they will move from the lower energy state to the higher energy state. Okay, and so that this electron, so it's not stable lah. Okay, because it shifts to another state, kan? So they will return back to their their original position. They will return back to their normal level, and at the same time, during their transition to move from the higher energy state to the lower energy state, they will release energy. They will release energy in form of radiations. Okay. So this is the process of excitations. Okay. So different lah process between ionization and also excitations. There are two different processes. Okay. Alright. So understand about excitation and ionizations. So this process actually you must understand lah, because this is a basic concept for you to understand radiation for you to understand the radiation interactions. Okay. Later on you will learn about radiation interaction with Dr. Nazifa. So it is the basic concept is excitation and ionization. Okay, so it is important for you to understand between this process. Okay, for ionization, it is the electron will be removed, right? For the excitation, electron will remain in the atom, but it will be excited to the higher energy level. Okay, so that is excitation process. Okay, understand? Boleh faham ke? Can you understand? Kedah saturated dah ni. Okay. Senyap macam ni? Ke saya cakap seorang dah ni? Are you guys still okay? Zawawi, are you okay? Okay, alright.
Okay, Doktor.
Okay. So,
Masih bertahan.
masih bertahan. Okay, ni ada sikit lagi ni. Okay. So, apa beza between ionization and excitation? What's the difference between ionization and excitation? Anyone want to refresh or recall what you have learned just now? Or want to try, want to test your understanding? Fahmi. Fahmi. Okay, Fahmi. Fahmi ada tak? Ke Fahmi keluar gelas ni? Nak tengah hari ni. Okay, Fahmi. Apa beza Fahmi between ionization and excitation?
Ionization tu dia ada cukup energy dari radiation, dia remove electron from the shell.
Okay. What about excitation?
Excitation, dia elevated that there is no insufficient energy to remove the electron. So the electron is just elevated from the shell.
Okay. Betul-betul. What about Ain Syazwani? Ain Syazwani?
Yes, saya.
What's different between ionization and also excitation?
Kalau ionization dia cukup energi untuk buang elektron.
Okay. What about excitation?
Kalau excitation ni dia macam elektron ada low macam ni sebab macam ni energi dia low. Low than banding energy.
Okay.
Kat elektron. So elektron akan
okay, so
rise from lower shell to the higher level. Dekat dalam atom, dekat orbit tu. Lepas tu elektron tidak boleh di remove from atom. Macam tu. Stable orbit akan jadi kepada normal lah.
Alright, okay. Husni. Okay, Husni pula. Okay, cuba Husni. Okay, differentiate between ionization and also excitation. Ada tak Husni? Husni? Oh, Husni. Ada ke kat situ? Ada ke awak? Husni. Husni. Ada tak Husni ke? Anyone want to try? Anyone want to test? Okay, siapa tu? Husni ke?
Ya, saya.
Okay, Husni.
For ionization process tu dia radiation radiation energy tu dia must be sufficient to remove the electron from the atom and dia punya have a high energy than its binding energy.
Okay, so the energy of incoming radiations is higher than energy of the binding energy of electron, right? So what happened to the electron during ionization process?
So dia remove the electron.
Okay, so electron will be removed from the atoms. Okay, so what about excitation?
Excitation process tu the radiation energy lower than the binding energy of the electron.
Okay, then what happened to electron in excitation?
So the electron will be rise from a lower shell to a high shell level.
Okay, all right. So correct. So anyone else want to test their understanding for ionization and excitation? Ada lagi tak?
Doctor.
Okay, siapa tu? Fatihah.
Fatihah, I have a question.
Okay, Fatihah.
Saya ada soalan, boleh ke nak tanya?
Boleh. Soalan apa?
Kan in ionization process, kalau incoming energy dia equal to its binding energy, dia boleh remove electron ke?
Boleh. Yeah, as long as it is equal or higher energy compared to the binding energy of electron. Okay, it must be equal or more than binding energy of electron so that they can remove the electron. Okay, but for the excitation, the energy is lower than binding energy of electron, so they cannot remove lah. So they just will excite the electron. Okay. Any more question? Alright. Okay.
Excitation tu kan electron tu akan macam change from lower to higher je. Kenapa dia dikira unstable dia?
Unstable?
Unstable. Kenapa macam elemen tu dikira unstable macam tu?
This one sebab it's not their orbit. Sebab kalau kat sini dia tak ada pengosongan elektron, betul tak? Okay, dia maksudnya bila dia rise to the higher level, so that the higher level they will excess number of electron, right? Betul tak? Okay, so that it's not stable lah. Because supposedly katakanlah the K shell supposedly they have two electron. For L they have 8 number of electron. So let's say electron for the K shell they are lifted to the L shell so that there are excess number of electron in the L shell, right? So that's why it's full. So that's why they will go back to their ground level. Boleh?
Okay, faham. Saya ingatkan dia cuma exchange tempat.
Tak, maksudnya dia akan turun semula, dia akan kembali semula lah masa elektron tu. Dia just naik sekejap and turun balik. Dia excitation. They excite from they got energy from the incoming radiations, so they have extra energy. Okay, actually this incoming radiations, they will pass over their energy to the electron in the K shell, for example. So that the electron in K shell, they have extra energy. So that's why they can excite to the L shell. Okay, but there are extra number of neutron there. So they will go back to their original or their ground level. Okay, and they will emit radiation. It means that they will give off their energy tadi. Okay, can you understand?
Yes.
Okay, good. Alright. So okay lah. So you guys actually faham lah kan difference between these two process. So we move to the last part of the lecture. Okay. This lecture, this one put is related with the energy level of the electron. Okay. So it's about luminescence. So what is luminescence? It is a process of in the materials where the light photon are generated in response to the stimulations. Okay, so basically what is luminescence? It is a process where the light photon are emitted. The light photon is cahaya lah. Okay, the light photon are emitted. Okay, so for luminescence, there are 4 phenomena. Okay, so there is fluorescence, there is phosphorescence, there is thermoluminescence, and also there is scintillations. So all these 4 phenomena are categorized as luminescence. Okay, so all these 4 phenomena, basically all these are the process to produce light. Okay, in these 4 phenomena, they will produce light photon. Okay, but they have different properties. They have different process. Okay, and normally these occur in the crystalline semiconducting materials. Okay. Okay. So, for you to understand about what is luminescence, how are their operations. So the first thing you have to know about electron band theory. Okay, so what is electron band theory? In electron band theory, there is it is about the transition of electron from the valence band to the conduction band, from the low levels to the higher levels. Okay, so these are the electron band theory for the luminescence process. Okay, so there is valence bands, there is conduction band, and there is luminescence center here, the place where the light is produced. Okay, so this is the luminescence center, and also there is forbidden gap. Okay, this is forbidden gap where the electrons are trapped. Okay, so this so for example, like this is shell, this is orbital, this is lower orbital, this is higher orbitals. So this is forbidden gaps in between the shell, in between the orbital. Okay, so we go through one by one. So electron band, for the electron band theory, there is conduction band, there is valence band. Okay, so for the conduction band, it is a region where the electron can move freely through the materials. Okay, so it is the conduction bands. And for the valence band, the electrons, they are actually bounded to the nucleus of atom. Okay, and electron that remove from the valence band, they will create holes. Okay, so the valence band, electron pada valence band, they are bounded to the nucleus. Okay, but if they are moved, or if they are removed from the valence band, or if they are removed from the shell, they will create hole, vacancy. Okay, so that is valence band. Okay, and the next one, forbidden gaps. So forbidden gaps, there are in between the valence band and conduction band. Okay, so in this forbidden gap, supposedly electron cannot exist. Okay, because it's not a shell, or it's not orbital for the electron. Okay, so supposedly at this region, at this forbidden gap, electron shouldn't exist. Okay, and then doping process. Okay, for you to understand the luminescence process, you should know about doping process. So what is doping process? So it is the impurity or doping agent that added during manufacture of semiconductor. Okay, so for luminescence process is occur normally in semiconductor materials. Okay, and for the luminescence to occur, okay, normally the impurity or the doping agent will be added to the semiconductor materials during its manufacturing. Okay, and doping agent, it is known as activator that introduce permitted energy levels or luminescence center into forbidden gaps. So that is doping agents. Okay, it is activator that introduce or permit it is activator that allow or that produce that allow the luminescence center to produce light, okay, into forbidden gap. Okay, so so these are example for doping agent. For example, like gallium, phosphorus, silicon, germanium. Actually banyak lah. Actually there are so many doping agent. Doping agent ni normally in semiconductor, normally the katakanlah the two elements it is combined together. For example, like lithium and fluoride. Okay, so they combine together. So each of them they become doping agent. They become activator. Okay, so by having this activator, so that the luminescence there is energy level in between the valence band and conduction band. Okay, kalau ikutnya valence band and conduction band it is forbidden gap kan. In between them there is forbidden gap. Supposedly there is no electron. Okay, but by having this activator or this agent, this doping agent, so that in between them they will have luminescence center that were able to produce light during the electron transition. Okay, it's a bit complicated lah, but hopefully you can understand lah. Okay, okay. So electron traps. Okay, so electron traps. The electrons they will trap in the forbidden levels. Okay, that's why it's known as electron trap, because supposedly at the forbidden level, forbidden gap, supposedly there is no electron. Okay, but whenever that electron trap happen, so there is extra energy level in between the valence band and conduction band. There is extra energy level in the forbidden gaps. Okay, and the electron that trapped in the forbidden gap, they can only be released if they have gain energy to jump to the conduction band. Okay, so this electron that stuck or that trapped into the forbidden gap, they can only be removed from the forbidden gap if they have energy to transfer to the to jump to the conduction band from the forbidden gap. Okay. Okay, so you can understand ke? Can you guys understand? Akmal?
Boleh kata insyaAllah.
Okay, so hopefully kalau you tak faham, you bertanya nantilah. Okay. So this is the concept for the luminescence process. Okay, luminescence mechanism. They add impurity or doping agent inside the materials, so that the luminescence center will exist in between the valence band and conduction band in the materials. Okay, so the first one is fluorescence phenomena. So fluorescence phenomena, it is all this actually produce light, kan? So as I mentioned earlier, this phenomena, fluorescence, phosphorescence, thermoluminescence, scintillation, all these produce light, a process to produce light by materials. Okay, so for the first one, for the fluorescence, it is the ability of the materials to emit light promptly in response to excitation from the valence band to conduction band within one nanoseconds. Okay, so means that their light emission is promptly, instantaneously, very rapid, sangat cepat lah light terhasil. Okay, meanwhile for the phosphorescence, the materials emit light, but there is delay in the emission of light. Okay, in response to the excitation. Okay, so that is fluorescence. Okay, so for the fluorescence, the light will be emitted promptly. Okay, the light will be emitted, apa nama tu? Dalam masa yang cepat lah. Okay, during the excitation process. But for the phosphorescence, for the light emission there is delay. Maksudnya light tu lambat sikit terhasil compared to the fluorescence. So that is the phosphorescence. Then for the thermoluminescence, so thermoluminescence, it is similar to these two. Okay, but the electron are trapped in the forbidden gaps. Okay. So the electron can only be released whenever they are exposed to heat. Okay, so that is the thermoluminescence. Okay, after the materials is exposed to heat, so that they will give off the light. Okay, so means that there is delay in the they will produce light, but they need stimulation to produce light. Okay, in this case of thermoluminescence, they require heating. Okay, they require heating for them to produce light. Okay, so that is thermoluminescence. Okay, and then for scintillation, it is similar to fluorescence. Okay, so the materials will produce light promptly. Okay, in a rapid period. Okay, but they emit flash of light. Okay, kalau fluorescent ni material tu akan menghasilkan cahaya kan. Okay, menghasilkan cahaya whenever they are stimulated, so they will produce light sekali je lah. But for scintillation, they will emit series of flashlight. Okay, means that after you stop pun, let's say after you stop stimulations, the scintillation they may still glow. Okay, the material may still glow. Okay, because they emit series of light flash. Okay, boleh faham tak? Can you understand? Izzatul, ke saya cakap seorang ni?
Boleh tak?
Boleh. Hopefully you all boleh faham Okay, kalau faham nanti you all baca balik lah. Tak faham you all tanya. Okay. Okay, so these are the difference between them. Okay. So how they process? Okay. So for fluorescence, this fluorescence they have many luminescent center. Okay, in between the valence band and the conduction band, there are luminescent center. So they have many luminescent center. Okay. Okay, so this is the process of fluorescence. Okay, so whenever there is stimulations, for example, like from radiations, kan? So the electron from the valence band, they will lifted to the conduction band. Okay, but in fluorescent band, there is no forbidden gap. Means that the electron will cross the forbidden gap. Okay, so means that for fluorescent, the electron they won't be trapped. They won't be trapped by the forbidden gaps. Okay, so the electron will straight away from the valence band go up to the conduction band. Okay, and conduction band is not stable. They will go down to the valence band and they will release light. Okay, during their return to the valence band. Okay, so that is the fluorescence process. Okay, and then for the okay, these are example for the fluorescence lah. Okay, and actually, so they have different material lah compared to the phosphorescent. Okay. Okay, so normally in radiography, there are so many fluorescent phenomena. For example, like intensifying screen in the film cassette. Okay, so they use fluorescent phenomena lah. Okay, in the image intensifier in fluoroscopy, this also use fluorescence principle. Okay, and then for phosphorescent. Okay, so phosphorescent, the difference between fluorescent and phosphorescent, for the phosphorescent, the electron are trapped in between the conduction band and valence band. Okay, for the fluorescent band, the electron won't be trapped. Tak terperangkap di forbidden gap. Okay, but for phosphorescent, there is the presence of the electron trap between the conduction band and valence band. They are trapped in the forbidden gap. Okay. Okay, so that so they are trapped here. Okay, so they will it takes time for the electron in this trap to go up to the conduction band. Okay, because from the valence band, some of the electron will go up to the conduction band, but some of the electron will trapped by the forbidden gaps. Okay, so that's why it takes time for the fluorescence to produce light due to this trap. Okay, and then the thermoluminescence. So thermoluminescence, okay, it is similar to the phosphorescence, but the difference is that the electron trap is situated a bit far from the conduction band. Okay, so you can observe here. So you can look at this picture. For this phosphorescent, the forbidden gap here is close to the conduction band. Nampak tak? Can you see? Can you see here? Ada tak ni? Ke saya cakap seorang tadi? Are you guys still there?
Nampak tu.
Okay, nampak kat sini kan? Okay, so kalau you tengok kat sini, for phosphorescent, the forbidden gap is close to the conduction band. Okay, so that the electron for the valence band, they will trap here, but easy for them to go up to the conduction band because they are close to the conduction band. This gap ni. Okay, but for the thermoluminescence, the electron trap situated a bit far from the conduction band. Okay, so look at here. For the thermoluminescence, the forbidden gap located far from the conduction band, so that the electron here cannot go up to the conduction band because it's far for them to reach. Okay, so that these materials, they require heating. Okay, so for this material, for them to release the electron from the trap, they require heating. The material must be heat first, so that the electron can be lifted to the conduction band. Okay, so that's why for thermoluminescence, they will produce light only after heating. Okay, only after heating. So, okay. So for thermoluminescence, normally is used in in monitoring radiation dose. You pernah pergi praktikal ke? Ada tak? You guys dah pergi praktikal ke? Ke belum? Dah kan? Tahun 2 dah kan? Pernah ah. You ada tak OSL ke film bash ke ada kan? Ada tak? Tak ada? Ada.
Hari tu kita praktikal dalam sebulan macam tu je. Tu tak dapat lagi TL.
Okay, tak apalah, it's okay. So this thermoluminescence ni normally dia guna untuk radiation dose monitoring. Okay, normally untuk TLD, film bash, kalau you perasan kan, kalau you pergi praktikal kan, radiografer akan pakai film bash yang kalau biru tu. Perasan tak kat dia punya baju tu? Dia punya tag ke kan? Ada tak nampak? Ke tak perasan ni? Nampak tak? Okay, so kalau you perasan, that film bash or that TLD, it use this concept. Mean that radiation, it used to measure dose to the staff lah. Okay, so that they will measure the radiations that exposed to the staff. So they store the radiation energy in the materials inside the film bash of the LD too. Okay, so when heating, so that you can measure the dose that received by the staff. Okay, so that is the concept of thermoluminescence. Okay, so the last one is scintillations. So scintillation, it is similar principle to the fluorescence, but they produce series of light flash. Okay, and normally they use in they use their material is phosphor, and their phosphor too made of scintillation crystal. Okay, so their material is scintillation crystal. For example, like natrium iodide. So that is their materials. It is scintillation crystal that have scintillation principles. Okay, so similar to fluorescence, they emit light simultaneously, promptly, but they emit series of light flash. Okay, so the the disadvantage for the scintillation is that they emit series of light flash. Means that even though after you have stopped the simulations, even though you have stopped the process, you have stopped the you have stopped the radiation lah kita panggil kan, but the material still emit light. Okay, they are also known as afterglow. Even maksudnya after irradiation, the material still glowing, still emit light. Okay, so that is the scintillation principle. Okay. Okay, so normally it's used in gamma camera. Gamma camera ni untuk nuclear medicine. You takkan jumpa lah dalam radiografi. Okay, it is in nuclear medicine. Okay, but it is also used for the imaging lah. Okay, but they use different principle. They use gamma, okay, gamma ray, not X-ray lah. Okay, so far so good. Are you guys okay? Ada lagi ke tak ada ni? Ke saya cakap seorang ni? Dah tengah hari dah ni?
Ada Dr. Elsa.
Okay, ke semua dah flat dah ni? Okay lah. So any question so this is so any question before we proceed to quiz? Ada soalan tak? Okay. Hopefully you guys can understand lah. Okay. So nampak simple actually. Nampak simple. You learn about such of matters, atom, proton, neutron, electron. But there are certain things that you must be able to differentiate between them. For example, like binding energy level between them, the energy level of the electron itself. Okay. The isobars, okay, and ionization and also excitation process, okay. Okay, is there any question before we proceed to quiz? Macam okay ke? Akmal okay, Akmal?
Okay.
Okay. Okay lah. Dah tengah-tengah hari ni, semua dah lapar dah tu. Okay, sebelum saya sambung dengan quiz tak? Sikit je. Okay, to test your understanding lah. Okay, shall we proceed to quiz? Boleh? Kita proceed quiz kejap.
Boleh.
Alright. So, saya share dengan you all link sekejap. Okay. Please bagi nama betul you all dalam quiz tu. Apa saya tengok nama macam-macam ni, tak kenal ni. Okay, bagi nama betul lah. Okay, write your short name lah. Akmal, tulis Akmal. Okay, sebentar saya share link dulu. Okay. Okay, so you type joinmyquiz.com. Then the code is 656890. 656890. Okay. 656 Okay.
Doktor, apa kod
Ya.
dia tadi doktor?
Sorry, macam mana?
Kod.
Kod dia 656890.
Okey, terima kasih.
Alright.
Doktor,
Ya. Sorry.
website dia apa? myquiz.com.
Quiz. Saya share dekat link. Jumpa tak? Quiz. You type je quiz. Join myquiz.com.
Join myquiz.com. Okay, kejap ya.
Boleh ke? Tak ada apa sangat. Question simple je to test you understand ke tak lah. You faham ke tak apa yang belajar tadi lah. It's just simple question. Siapa ni cincau segar ni? Ya Allah. Cincau segar mana pula ni? Siapa selalu hina isteri 4 ni? Aduh, you all ni. Macam-macam. Kokoci ni siapa? Kokoci ni boboiboy ke? Sama macam anak saya suka boboiboy ni. Saya pun tahu nama boboiboy ni.